Hello everyone, I am Orca, and today I'm going to break down these linear questions for you. We're starting from page 54 to 58. Right, so now let's get started. I'll explain it in simple ways so you won't get any confusions while listening to me. Alright, so question 1. The limit of 3x plus 2 as x approaches 2. So this is a simple linear function. We substitute x to 2 directly into the expression, and that would give us 3 times 2 plus 2, which is 6 plus 2, and so our final answer is 8. So next question. So this is also simple. We substitute x equals 4 directly into the function, and so we will get 4 plus 2, which gives us 6. Number 3. So this is a bit more complicated and more advanced than uh, the earlier two, but we could pretty much get through it uh, pretty easily. So we substitute x approaches 6 into the expression. So we will get 6 minus 6 over 3 equals 18 minus 6 over 3, and we will get 12 over 3. So we divide these two and we will get 4, which is the final answer. Alright, so number 4. So you'll notice there's no x variable here, like this. There is no variable. So remember that the limit of a constant is always that constant itself, regardless of what x approaches. So the answer is simply 3. Alright, number 5. The limit of x power 2 plus x plus 1 as x approaches minus 1. Uh, I will explain it briefly. So you should be careful with negative signs here. We substitute x equals minus 1 into the function. So we will get minus 1 power of 2 plus minus 1 and plus 1. So since minus 1 power of 2 in the bracket is 1, we get 1 minus 1 plus 1, so which equals 1. Alright, number 6. The limit of x power of 2 minus 3 as x approaches 2. So we substitute x approaches 2 directly into the expression to get the 2 power of 2 minus 3. Well, that becomes 4 minus 3, giving us an answer of 1. Pretty simple, right? Alright, number 7. We plug x into the function, like directly. Uh, that is 16 plus 6, which equals 22. Alright, so question number 8. The limit of x power of 2 plus 4x as x approaches minus 4. So we substitute x uh, equals minus 4 into the expression. The first term is minus 4 power of 2, which eventually becomes 16, and 4, and minus 4 in the brackets becomes minus 16. So we should add them. Together, we will get 0. Alright, number 9. Uh, so we substitute x equals 2 into the function directly, which we will get 1 minus 2 equals minus 1. Very simple. Alright, so number 10. Just like problem number 1. No, number 4. So, -1 is a constant. As x approaches -6, the constant remains unchanged. So the answer is -1. Number 11. So the limit of x power 3 plus 2x minus 6 as x approaches 4. We substitute x as it approaches 4 into the function. 4 power of 3 is 64, and 2 times 4 is 8. So we combining them, we will get 64 plus 8 minus 6. We uh, add them up, and then minus 6, we will get 66. Or the last question of this page. Question 12. The limit of x power of 2 plus 1 over x minus 3 as x approaches 1 minus 1. This is rational expression, so we substitute x uh, as it approaches -1 into both the numerator and the denominator. So the numerator is this one. We'll get -1 power of 2 plus 1, and which gives us plus 1, 1 plus 1. And the denominator, which is -1 in the brackets, and then we minus 3. We will get -4. That will give us 2 over -4, which simplifies down to -1 over 2. Alright, moving on. Alright, I'll give you some facts, which could be interesting for you. A non-zero number divided by 0, which means the limit does not exist, or DNE, as you can see here. And the indeterminate from 0 over 0, where we must simplify using factoring, canceling common factors, or LH rule. So let's begin. The limit of x power of 2 plus 9 over x plus 2 as x approaches -2. Alright, so we should try direct substitution with x equals -2. The numerator becomes -2 power of 2 plus 9, which equals 13, but the denominator becomes 0. That means it is undefined in real numbers, so this limit does not exist. Number 14, the limit of x power of 2 plus 4 over x minus 4 as x approaches 2. We substitute x equals 2. The numerator is 2 power of 2 plus 4, which is 8, as we can see here. And the denominator is 2 minus 4, which gives us -2. Dividing 8 by -2 will give us 0 of -4. Sorry. And number 15, the limit of x power of 2 and plus 3x over x as x approaches 0. So we are plugging in x as it approaches 0. We'll get 0 over 0, which is an indeterminate form. Well, so you'll notice that we have two ways of solving this. Alright, factoring method. We should factor out an x from the numerator to get x, uh, open bracket, x plus 3, close bracket, over x. We cancel out the x from the top and bottom to leave x plus 3. So we substitute x as it approaches 0 to get 3. As you can see here, this is the final answer. And we can also use LH rule, which we should differentiate the top and bottom with respect to x. The derivative of x power 2 plus 3x is 2x plus 3. And the derivative of x is evaluating 2x plus 3 over 1 at x approaches 0, which will give us 3, like this one. Number 16. The limit of x power 4 minus 5x power 2 over x power 2 as x approaches 0. Direct substitution yields 0 out of 0. Factoring method. Start with this one. We factor out x power 2 from the numerator. So we cancel x power 2 out to get x power 2 minus 5. Yeah, you don't mind this. You don't care about this one. Which yields us minus 5. As you can see here, the process. And the LH rule, we should differentiate the 4x power 3 minus 10x over 2x. Factoring out x, like all of these, will give us 4. This will get 0, 0, 0. Yeah. And we should evaluate x as it approaches 0. Like you couldn't 0 times anything it will equals 0. So we will get only zeros. And the final answer is 0. Right, so 17, the limit of x power 2 minus 1 over x plus 1 as x approaches minus 1. Direct substitution gives us 0 over 0 as usual. Factor the numerator using the difference of squares. So we should get x minus 1 and x minus 1 with x plus 1. And this is the solution, minus 1, minus 1. We should also add these two. We'll get minus 2. Right. So the next method is to cancel out x plus 1 from both numerator and denominator, leaving only x minus 1. We should plug in x as it approaches minus 1 to get minus 1 minus 1 equals minus 2. Number 18. So let's start with, so given this question, we should plug in x as it approaches minus 2, which will give us 0 over 0. Factor the quadratic numerator into 3x minus 1 and x plus 2. We should cancel out the from top and bottom to get 3x minus 1. So we substitute x as it approaches minus 2 will gives us 3 minus 2 minus 1 will equal minus 7. Alright, so question 90. The limit of x power 3 minus 8 over x minus 2 as x approaches 2. So direct substitution gives us 6 over 0 over 0. Factor the numerator using the difference of cubes formula. So we should get x minus 2 and x power 2 plus x and 2 plus 2 power 2 over x minus 2. So we should add all of this and power of 2. We will get the same answer as on top, which is 12. So let's give some methods. So 3x power 2 over 1 equals 3 oh, 2 in the brackets, power of 2 and minus 3 4 in the bracket. So you should get 12, same one as the bottom. Alright, so number 21, the limit of x over x power 2 minus x as x approaches 0. So direct substitution as usual, you should get 0 over 0. So out from x from the denominator, there's no factor. So we should cancel x to get 1 over x minus 1. Substituting x as they approaches 0 yields 1 over 0 minus 1. So we should get 1 over minus 1. Simplifying this, we should get minus 1 as the final answer. Number 22. So my main method that I use here is LH, which is 2 over 2x plus 4. So we should get 2 over 0 plus 4. So adding this 2 up, we'll get 2 over 4. Simplifying this, we should get 1 out of 2. This is the same, you will get the same answer. Alright, so number 23. The factor. Let me see. We can also use this direct substitution to get 0 out of 0, but this one can also be used as well. So we should get a limit x minus 4, and as x approaches 4, we should get x minus 4 and x plus 4. Why? Because here we have to minus the 16 with x power 2. We should get these 4. With that, we we would get 1 over 4 plus 4 equals 1 over 8. Alright, so last question of this page, number 24. The limit of 5 minus x over x power of 2 minus 25 as it approaches 5. So the direct substitution gives us 0 over 0. Factor the denominator as x minus 5 and x plus 5. So we should rewrite 5 minus x in the numerator as minus x and minus 5 in brackets. So we should cancel x minus 5 inside the brackets to get minus 1, like this, and over x plus 5. So we substitute x as it approaches 5 to get minus 1 over 5 plus 5. And the final answer that we get is minus 1 over 10. Now for page 56. Alright. Number 25, the limit of x power of 2 plus x minus 6 over x power of 2 minus 9 as x approaches 3. So let's substitute x. X equals 3, so the numerator gives 3 power of 2 plus 3 and minus 6. And the denominator is 3 power of 2 and minus 9. So we multiply the powers together, we will get these. For right here, you just bring it right here, like this one. And so we will get 6 over 0, which we are actually dividing a non-zero number by 0. So the limit does not exist. It is undefined. Number 26. So as usual, we substitute them to get 0 out of 0. Apply LH rule. Derivative of the numerator 2x plus 2, and the derivative of the denominator is 2x minus 1. We should substitute x as it approaches 2 to get 2 and 2 in brackets plus 2 over 2 in the brackets minus 1. Simplifying all of these, we should get 6 out of 3. Dividing these two will get us 2 as our final answer. Alright, so question 27. Root x plus 5 minus 3 over x minus 4 as x approaches 4. Substitution gives 0 out of 0, as usual. Since we have a radical term, multiply numerator and denominator by its conjugate. So, root x plus 5 minus 3. The numerator simplifies via a minus b, a plus b equals a to b2 into x plus 5 minus 9, like this, equals x minus 4. So we cancel x minus 4 with the denominator to get 1 root 9. No, 1 over root x plus 5 plus 3. So we plug in x as it approaches 4 to get 1 over root x plus 5 plus 3 equals 1 root 4 plus 5 plus 3. So we evaluate this, we get 1 over 3 plus 3, and the final answer is 1 out of 6. Moving on to number 28. So the limit of x plus 1 minus 2 over x minus 3 as x approaches 3. Usual, 2 plus 2 minus 2, and 3 minus 3 will get 0 out of 0 as substitution. So we multiply top and bottom by the conjugate, like root x plus 1 plus 2. So numerator becomes x plus 1 minus 4 equals x minus 3, which cancels out with the denominator. With that, we are left with 1 over root x plus 1 plus 2. We substitute x equals 3 to get 1 root over root 4 in brackets plus 2 equals 1 added 2 plus 2. So we plus these two and we'll get the final answer 1 over 4. Question 29. So, give me a second. Alright, I get it. So substitution 0 out of 0 multiplied by conjugate. We'll get root x plus 5 plus root 5. The top becomes x plus 5 minus 5 will equals x, which cancels with x in the denominator. We get 1 out of root x plus 5 plus root 5. Substituting x as it approaches 0 yields 1 out of root 5 plus root 5 equals 1 out of 2. Or rationalize as root 5 over 10. Alright, number 30. So we multiply top and bottom by the conjugate. Root x plus 9 plus 3. The denominator simplifies to x plus 9 minus 9 equals x, which cancels x with x in the numerator. We get 2 root 1 out of 2 with x plus 9 in the brackets minus 1 over 2. So the method is to multiply with this and with 9 and 1 over 2. We'll get like this. So we'll get 1 out of 2. We cancel this out. And then we would get the number 3 in this bracket. So we will get 4 times 3 equals 12. Alright, for the exercise 2.2, number 1, the limit of root x minus 5 as x approaches 5. Approaching 5 from the right gives root 5 minus 5 is 0, like this. Approaching 5 from the left gives negative values under the radical, which is undefined, like this. Since the left-hand limit does not exist, the overall limit does not exist as well. Yes, it is not equal. Number 2. Also, root x plus 2 minus root 0 as x approaches minus 2. Approaching minus 2 from the left gives negative values under the radical, which is undefined. Because left hand and right hand limits do not match, the limit does not exist. So number 3, same thing. So approaching 0 from the right gives root 0 equals 0, but approaching from the left is undefined. So since both sides must agree, the limit does not exist. Again, number 4, the limit of root x plus 3 as x approaches minus 3. Approaching minus 3 from the left produces negative values under the radical, making the left-hand limit undefined, like this. So, therefore, the limit does not exist. Again, number 5, the limit of absolute x minus 2 as x approaches 2. So absolute value functions are continuous everywhere, so we could plug in the x as it approaches 2 directly. So absolute 2 minus 2 equals absolute 0, and our final answer is 0. Number 6, the limit of absolute x plus 1 as x approaches minus 1. So we could substitute this one directly into the function. So absolute 1 plus 1 equals absolute 0. So absolute 0 will equal 0. The final answer is 0. Moving on. Page 57. The limit of absolute x minus 5 over x minus 5 as x approaches 5. For the left-hand limit, x 5, absolute x minus 5 is minus x minus 5, giving minus x minus 5 over x minus 5 equals minus 1. For the right hand, x 5, absolute x minus 5 is x minus 5, giving x minus 5 over x minus 5 equals 1. Since 1 minus 1 and 1 over the overall limit does not exist, it does not match. Number 8. The limit of x minus 1 over absolute x minus 1 as x approaches 5. So you should pay close attention to x approaches 5, not 1, since 5 is more than 1. So the expression inside the absolute value is positive. Direct substitution yields 5 minus 1 absolute, 5 minus 1. So we will get 4 out of 4 equals 1. So number 9. The limit of x and x in the bracket as x approaches 2, where f and x in the brackets equals x plus 1. For x 2 and f and x in the brackets equals 2. For x 2, left-hand limit substitute x equals 2 into x plus 1. So to get 2 plus 1 equals 3, like this. And right-hand limit, the function is constant as 2. So since 3 and 2 does not equal to each other, the limit does not exist. The limit of f and x in the bracket, where f and x equals x plus 2 for x 3, and fx equals x minus 5 for x 3. Alright, so left-hand limit, substitute x to equals 3 into x minus 5 to get 3. To get 3 minus 5 equals minus 2. So right-hand limit, substitute x equals 3 into x plus 2 to get 3 plus 2. And that will give us 5. And again, since these two is not the same value, the limit does not exist. Number 11. So the limit of f and x in the brackets as x approaches 2, where f and x in the brackets are x power 2 and x are more than 2, and 2x and x is lesser than 2. Left-hand limit, substitute x equals 2 into x power of 2 to get 2 power of 2 equals 4. And our right-hand limit, substitute x equals 2 into 2x to get 2 and times 2 equals 4. Now, this time it is the same. So both side limits are equal. The overall limit is 4. Number 12. The limit of f and x in the brackets as x approaches 4, where f and x in the brackets are equal x power of 2. For x is more than 2, and f and x in the brackets equals 2x, for x is lesser than 2. Since x approaches 4, we are strictly in the domain where x is lesser than 2. So we use f and x in the brackets equals 2x. We substitute x, we'll get 4. To get 2 and 4 in the brackets, which we will multiply, and then we will get 8 as our final answer. Alright, now we are on the final page. So question number 13, given function x, defined as x power of 2 for x more than 3. And number 7, for x equals 3, and 2x plus 3 for x lesser than 3. We should find the limit as x approaches 3 and find function 3, like what the problem says. So our left-hand limits is 3 power of 2 equals 9. And right-hand limit is 2 times 3 plus 3, I read it wrong, is 9 as well. For f and function 3 in the brackets, use the exact value defined at x equals 3, which is 7. So we'll get 7 as our final answer. This one is also a limit. The overall limit is equal. And for our final question, given the f and x in the brackets is absolute x minus 1 over root 1x. And for x, like normal x, we'll get absolute 1 minus x over 1 minus root x. For x lesser than 1, we should start with this. Alright, our left-hand limit is x more than 1. Absolute x, the fraction becomes x minus 1, root 1 minus x. So equals root minus root 1 in a bracket with substituting x equals 1, which we will get minus root 0 equals 0. Now for our right-hand limit is x lesser than 1. So absolute 1 minus x equals, 1 minus 1 minus x. The fraction becomes minus 1 and minus x in brackets over 1 minus root x equals minus 0 and over 1 minus 1, which we will get 0. Substituting x will gives us 1. So minus 1, no, minus 1 plus root and 1 in brackets. We'll get minus 2, so these two does not match. So since 0 is not the same value as 2, the limit does not exist. And that concludes our guide video. Hope you guys enjoy. Leave a like and subscribe to my channel. And I'll see you guys in the next video. Thank you.